It's math time with Heinz. It's math time with Heinz. Math time.
Hi everybody, welcome to lesson 3 where we're going to be going over another division technique for when we divide polynomials. So in lesson 2, we were using the reverse tabular method to divide polynomials. Now we're going to take a trip back to elementary school and use the long division algorithm that you know and love since 4th grade. So before we get into that, let's do a quick little opening exercise here where I want you to divide 2x to the third plus 11x squared plus 7x plus 10. I want you to divide that by x plus 5 using that reverse tabular method that we went over in lesson 2. So pause the video right now before I go over and give you the answer on how to do it. Did you actually pause the video? I don't trust that you actually did. So I'm dividing by x plus 5, that's my divisor there. And then I'm going to make a box, and I don't really know how big I need to make that box, but I'm going to make that box somewhat large. And I know I have 2 rows because I have x and plus 5 as my divisor. I take my dividend, which is my numerator here, and that's what's coming out of the diagonals of my table. Well, I ran out of boxes, so I need to draw in a vertical line to give me a new diagonal. 7x, and then I need another vertical line and I get 10. So my diagonals are what give me those outputs there. Those diagonals there are what have to give me what comes out of the box. And we want to know what times x plus 5 gives me that answer. That's how we can think of division questions. So we're going to push that 2x to the third term back into the box. And then we ask ourselves, what times x gives me 2x to the third? What times x is 2x to the third? Well, hopefully you said 2x squared. But now that I have that upper piece, I can fill in my table more by saying 2x squared times 5 is 10x squared. But I don't want 10x squareds. How many x squared terms do I need? I need 11 of them. I currently have 10, but I need to get to 11 of them, so I need another 1x squared there to fill in that missing piece. And we start again. We start again by asking ourselves, what times x is 1x squared? Well, x times x is 1x squared. Come on, Sparky. Come on, you can, there he goes. X times x is 1x squared. X times 5 is 5x, but I need 7 of them, so 2 plus 5 gives me 7, and we start again. We ask ourselves, what times x is 2x? Well, 2 times x is 2x, and 2 times 5 is 10, so it checks out as I expected it to. So my quotient is actually what's on top of the box here. The answer to this division problem is 2x squared plus x plus 2, and that's hopefully what you got when you did it on your own there. What we're going to be doing in the future is using division to factor polynomials. And factoring is just writing it as a multiplication problem. So my question here is, how can I rewrite my dividend? How can I rewrite my dividend into its factors, into a multiplication problem? Well, let's look at this box and pretend like we didn't know that I just did division. I could view this as a multiplication problem. X plus 5 times my quotient gives me that third degree polynomial there. So the two factors are x plus 5 times 2x squared plus x plus 2. Those two factors multiplied together give me that output of the table. So in the future, you'll see this later on in the unit, we're going to use division to factor polynomials. Alright, that was enough with the reverse tabular method. Let's do some good long division. So let's take a trip back to elementary school and do some long division where we're going to divide 1,573 by 13. So inside my long division is my dividend 1573. And outside my little long division sign there, I'm going to put my divisor, which is 13. And then hopefully you remember what how these steps go. How many times does 13 go into 15? Once. 1 times 13 is 13. And then we subtract. And I get 2. And then we bring someone down. So I'm going to bring on down that 7 if my smartboard will let me write 7. There we go. And we start again. We start again and we ask ourselves, how many times does 13 go into 27? Well, that's 2 times. 2 times 13 is 27, so I get 26. Then we subtract. And then we bring it on down and bring it on back and start one last time. We ask ourselves, how many times does 13 go into 13? And of course that answer there is 1. Multiply. We've got to do 1 times 13, which is 13. And then we subtract, so we get a remainder of 0. So we're going to use this same process for when we divide polynomials. It's just going to look a little bit more algebraic, as it should. So we're going to do that exact same problem, but instead of using a base 10 number system, we're going to replace it with x. And here we go. Here's how this looks. So we ask ourselves, what times x? I only care about this x right now. I'm going to ignore that plus 3. I'm going to use the most powerful term there, that leading term. What times x gives me x to the third? Well, x squared times x gives me x to the third. So I get x to the third, but then I have to keep multiplying. X squared times 3 is 3x squared. So we multiplied. You have to make sure whatever you put on top in the quotient, you have to multiply the entire divisor by that. Now I need to subtract. But when we subtract, you can't just put a minus sign. You have to distribute that -1, that factor of -1, to all of the terms. So that's actually a negative 3x squared there. Goodbye, goodbye. Those guys add to 0, as they always will. 5x squared minus 3x is 2x squared. And then we bring it on down and start again. So it's the same process as numerical long division that we learned since 4th grade. It just looks a little bit messier because there's polynomials involved. So we ask ourselves, what times x gives me 2x squared? What times x gives me 2x squared? Well, 2x does. 2x times x is 2x squared. Keep multiplying. 2x times 3 is positive 6x. Well, now I need to subtract. So I'm going to distribute through a negative sign. I change everybody's sign in that row that I just wrote down there. Those terms will always add to 0, and I'm left with 1x. Bring it on down to 3, and I get 1x plus 3. And finally, one last time, we ask ourselves, what times x is 1x? The answer is 1. 1 times x is 1x. 1 times 3 is 3. This is looking promising, because when I change my signs to subtract, I get a remainder of 0. So my quotient here is x squared plus 2x plus 1. So you might be looking at this saying, Coach, I'm never doing this on my own. I just want to use the reverse tabular method. And you know what? That's okay to use. That is okay to do if you just use the reverse tabular method. I'm just giving you another option. So if you hate this and you feel like you've got the reverse tabular method down, great. If you didn't like the reverse tabular method, maybe you're a long divider. Maybe you're going to be a good long divider. So let's do another one before I let you try some on your own. Use the long division algorithm for polynomials to evaluate this expression. So we are dividing, by 2x minus 2. And what am I dividing? I'm dividing 2x to the third minus 4x squared. Hopefully, warning, hopefully your warning light's going off because I'm missing an x term. I have 0 x's. I need a placeholder put in there because I don't have any x's in that expression. So now I'm going to add my plus 2. So you have to remember, even if you're doing long division or the reverse tabular method, you need to account for every place value taken care of. If I start at x to the third, then I go to x squared, then I go to x. So you have to make sure you have all those place values taken care of. So let's see what we can do here. We're going to ask ourselves, Self, what times 2x gave me 2x to the third? What times 2x is 2x to the third? Well, that's x squared. X squared times 2x is 2x to the third. Keep on multiplying. X squared times negative 2 is negative 2x squared. So you multiply whatever you put up top by that divisor. Well, now we need to subtract. So I'm going to put a minus sign there and a plus sign there because I'm going to change everybody's sign. When I subtract, I'm really changing everybody's sign here. Those terms add to 0. Negative 4x squared plus 2x is negative 2x squared. Bring it on down. Bring everybody down there. And we start again. And we start again by asking ourselves, self, what times 2x is negative 2x squared? What times 2x is negative 2x squared? Well, that'd be negative 1x, I believe. Negative 1x times 2x, good. Negative 2x squared. Keep multiplying. Negative 1x times negative 2 is positive 2. Well, now comes that subtraction step, and how do I subtract? Well, I subtract by changing everybody's sign. That guy becomes positive, that term becomes negative. Goodbye, goodbye. And we're left with negative 2x plus 2. And we wipe the sweat off our forehead because we've got to do this one more time. What color should we use? I haven't used we'll use this magenta color here. What times 2x is negative 2x? Well, I believe the answer is negative 1. Negative 1 times 2x is negative 2x. Negative 1 times negative 2 is positive 2. And you might be thinking, well, that doesn't give me 0. Well, that's because I haven't changed my signs yet. Goodbye, goodbye, remainder of 0. So my quotient comes out to be, what is actually the answer? X squared minus x minus 1. That right there is my quotient. So you might notice that this takes a little bit longer than the reverse tabular method because the reverse tabular method you can get quick at, you're skipping steps, you're doing some of it in your head. This is more of a drawn out process, but it lets you see everything that you're doing along the way. So in number 4 here, I've got a bunch. If we were in class, I'd say, all right, folks, go work. I'll be around to help. So I've got A, B, C, D, E, and F. Those last 2 you don't have to do. So I've got 6 problems here. I'm going to do 2 more with you, and then I want you to try those remaining 4, and we'll see how things go. So I'm not expecting you to watch this entire video. I'm going to do these next 2 with you where I want you to watch it with me. And then C, D, E, and F, I'll talk through my work, but those I expect you to kind of do on your own. So let's get to it. I'm going to switch between long division and reverse tabular. I'm going to switch between both of them just so everybody gets to see whatever option they like. So for this first one, I'm going to use the reverse tabular method. For this first one here, just to show you how nice and compact the reverse tabular method is compared to long division. So I'm dividing by 7x minus 1. And then I take my numerator and put that on my diagonals. 7x to the third, negative 8x squared, negative 13x, and then 2. So I'm going to push that first term back in the box. And then I ask myself, what times 7x is 7x to the third? Well, x squared. X squared times 7x gives me 7x to the third. And then I'm going to keep on multiplying. X squared and negative 1 gives me negative x squared. But how many of those do I need? I need negative 8 of them. Currently I have negative 1. So I think of the ladder. Am I climbing up the ladder or am I climbing down the ladder? In this case, I think I'm climbing down the ladder. I'm going down 7 more. I need 7 more negatives to get me to negative 8. And we start again. We ask ourselves, what times 7x is negative 7x squared? Well, in this case, it's negative 1x. Negative 1x times negative 1 is positive 1x. Think of a staircase. I'm at floor number 1. I've got to get down, so I'm going more negative here. I've got to get down to floor 13. So how far apart is 1 from negative 13? How many floors do I actually have to travel? I need to go down 14 floors. Negative 14 plus 1 gives me negative 13. Always stop and check that those values actually add up correctly. And then one last time here, I'm going to ask myself, what times 7x is negative 14x? Well, negative 2. Negative 2 times negative 1 is positive 2. So my quotient does come out to be x squared minus 1x minus 2. That's where my quotient actually comes out to be. For choice B here, I'm going to use long division. I'm going to use the long division algorithm here just because it's a small enough problem. So x plus 3 is my divisor, and inside I'm putting x squared plus 6x plus 9. So now I'm going to go through the exact same steps as if I was doing the reverse tabular method. This is just going to be a more drawn out algebraic process. So I'm going to ask myself, what times x is x squared? Well, x times x is x squared, and x times 3 is 3x. Now I'm going to change my signs to subtract, negative, negative, goodbye, and I'm left with 3x plus 9, and we start again. That doesn't really look like a 3. We'll try that again. That's much better. We try again, and we ask ourselves, what times x is 3x? What times x gives me 3x? Well, that's 3. 3 times x is 3x. 3 times 3 is 9. This works out beautifully because when I change my signs to subtract here, I end up with a remainder of 0. So my quotient actually comes out to be x plus 3 as my answer. Don't just do what I did and box it in. Please actually write out what your answer is. So that wasn't too bad. Again, you could have made a table and done the reverse tabular method. Reverse tabular keeps it nice and compact, whereas long division over here kind of becomes a drawn out process. Whatever process you like, I'm okay with. I'll do a few more here. I'll do reverse tabular again to start this one off. So I'm dividing by x minus 3. What comes out of the box here? I have x to the third. Does a number come after x to the third in terms of place value? No, no way it does. So I need to keep thinking, what comes after x to the third? Well, I have 0 x squareds. Well, what comes after x squareds comes the plain old x place value. So I have 0 x's as well. And then comes my negative 27. So hopefully, warning, 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 hopefully you realized you needed some placeholders there. So let's start this off here. Let's start this off with this nice blue. I've got x to the third, push back into my table, and I'm going to ask myself, what times x is x to the third? Well, x squared goes there, multiply. And I like this problem because I have negative 3 and I've got to get back to 0. So I've got to climb up, I need to go positive 3x squared. 3x squared minus 3x squared makes 0. And then we start again. We ask ourselves, what times x gives me 3x squared? Well, 3x goes there. 3x times negative 3 is negative 9x. But I need 0 of them. I have negative 9. I have to go up 9 floors to get back to 0. And then one last time, what times x is 9x? Plus 9, it checks out, we get a remainder of 0. So this quotient actually comes out to be x squared plus 3x plus 9. Again, I'll do the next one using long division. I like reverse tabular method. You're still going to have to use placeholders if you did long division here, but I want you to see that both methods are okay to use. All right, here we go. Here we go. Take 2. I've got x plus 2 as my divisor, and then I think I have all my terms here. I do. I'm good to go. There we go. Seems okay right now. Seems like everything is going to be good to go. What times x is x to the third? Well, x squared times x is x to the third. Keep on multiplying. X squared times 2 is 2x squared. All right, Then I change my signs to subtract. You become negative and you become negative. Goodbye. 2x squared, oh no, goodbye. Goodbye, goodbye. Looks like I slashed everything out. This is weird, but you know what? I'm just going to keep on going. I'm going to follow the next step in my long division process, which is bring everybody down. So let's just bring everybody down and keep on going. I'm going to ask myself, what times x gives me 4x? Well, plus 4. 4 times x is 4x. 4 times 2, oh. So sometimes that's going to happen. And if you were doing a table right now, you'd have just a column of zeros because you wouldn't have needed to add anything. This middle column over here, you can't see me, I'm pointing at the board right now. This middle column over here would just be zeros. So weird things can happen and you just have to kind of go along with it and hope for the best. So when I change my signs to subtract here, we end up with a remainder of 0. So my quotient comes out to be x squared plus 4. That's my answer right there. The answer just happens to be x squared plus 4, and hopefully the smartboard stops disconnecting like it did this entire video. So, hopefully you feel comfortable with one of these methods because they're really the same thing, they're just visually different to look at. One is more organized in a table where you do a lot of mental math. One is more of an algebraic, drawn-out process where you're showing all your steps. That's all I've got for lesson 3, and I'll see you in person or in the next video. Who knows when I'll see you again.